Okay, section 7.2 is rational numbers as exponents. So we have done this before, switching between writing terms as an exponent or as a radical, and so that's kind of what we're doing a little review of today. So here are just some of the rules. If you have a to the 1 over n, then this denominator becomes the root that you're using, so it's the nth root of a. A to the m over n, same thing, nth root of a, and then it's just raised to the m power. And you can write this either way. You can write it nth root of a all to the m power or the nth root of a to the m. So you just have to look at your numbers and decide, is it easier to raise the number to the power first and then take the root, or is it easier to take the root and make it smaller and then raise it to the power? And so we'll practice that a little bit today as well. The last one, and you already know this, when you have a negative exponent, you just move it under the fraction bar and it becomes a denominator. So make sure you please take a moment to get these rules written down in your notes. And now we'll practice, right, as a radical and simplify. So the first one is 16 to the 1/2 power, and so we take that denominator is a 2. The second root or square root of 16 is basically square root of 16, which is 4. So that number is obviously implied, but I was just showing you where it comes from. Number 2, the negative 8 to the 1/3 power. So now we have the third root, which is cube root of the quantity negative 8. And if you look back at your 7.1 chart, you'll see that if you take an odd root of a negative number, you get a negative answer. And the cube root of 8 is 2, so negative 2. And you can always double check that by saying negative 2 times negative 2 times negative 2 is negative 8. Alright, number 3 says the quantity ABC all to the 1/5 power is the 5th root of ABC. And number 4 is the quantity 25x to the 16th all to the 1/2 power. And so you can do this in, change it all to the square root first, square root of 25x to the 16th. And you can even break it up into the square root of 25 times the square root of x to the 16th if you'd like. Square root of 25 is 5. Square root of x to the 16th is x to the 8th. Here you can use our old multiplying rule, 16 a power to a power, you multiply them. 16 times 1 over 2 is 8. So now we're going to go the other direction. Write using exponential notation. So we have number 5, the 5th root of 9ab. So we have the quantity 9ab, and this is the 5th root. This is raised to the 1st power, so first a 1 is our numerator and a 5 is our denominator. So it's 9ab all to the 1/5 power. Number 6, 7th root of x cubed y all over 4. So we have this whole x cubed y over 4 all to the 1/7 power. And number 7, the square root of 5x is 5x to the 1/2. But if you write it like this, you're missing the term. This was the square root of the whole term 5x. So you need to keep that in parentheses. It's not 5 times x to the 1/2. It's 5 to the 1/2 and x to the 1/2. Okay, so now we're going to go back to the other direction. Right, as a radical. Number 8, 27 to the 2/3. So now our denominator is our root, so it's cube root of 27 and then squared. Now here's where you have to decide. Would you rather take the cube root of 27 and then square that number, or would you rather square 27 and take the cube root? Now I don't know what 27 squared is off the top of my head, so you probably don't either. So we can take the cube root of 27 is 3 and then square that, and that's something we can do in our head because 3 squared is 9. So now you try that. 25 to the 3/2 power. So take a moment, pause it if you need to, and try this. And we should see that if we take the square root of 25 cubed, I would rather take the square root of 25 first as opposed to cubing the 25. So the square root of 25 is 5, cubed is 125. Okay, so here are using the same types of problems, I guess you'd say, right, as exponents. So in the first chunk of examples, we had ones in the numerator. Now we have actual numbers like a 2/3. So now we're going to do that same thing going backwards. So we have the cube root of 9 to the 4th. And so we write 9, and we have to decide now which one goes on top. We're going to have a fraction bar, and it is the power, the 4 goes on top, and the root is always our denominator, so it's 9 to the 4/3. 4th root of 7xy, all to the 5th. Well, that's 7xy to the 5/4 power. Number 12, 9 to the negative 1/2. What happens with our negative exponents? They move below the fraction bar. We have 1 over 9 to the 1/2. And remember, this asks you to leave it as exponents, so you don't have to change that to square root of 9. Even though you know square root of 9 is 3, the answer is 1/3. But here we're just leaving it. Bye, Brandon. Thanks. 5xy all to the negative 4/5 power. So again, this whole term is raised to a negative power, so we move it below the fraction bar. 5xy, and now we have to the positive 4/5 power. We're leaving our answers as exponents. Alright, let's do one more of these. 4x to the negative 2/3 y to the 1/5. Now you should be so good at these because we've done them. So we ask ourselves, the 4, what exponent does the 4 have? And does it stay or go? Well, it has an exponent of 1, it's positive, so it stays on top. But now this x to the negative 2/3 has a negative exponent, and as we all know, negatives move. So it moves downstairs and becomes x to the positive 2/3, and our y to the 1/5 gets to stay on top. Cool? Happy day. Alright, this is important. You have used a lot of these without even knowing it, but these are the actual laws of exponents, so we need to make sure we get them down in our notes, and there's only 4 of them. If you have a to the m times a to the n, so you have the same base being raised to different powers, what do you do to the exponents? Right now you should be saying add. That is a to the m plus n. Now if you have a to the m over n, a fraction, what do you do? It's a to the, we subtract m minus n. This is also where we say, okay, which one wins, top or bottom, by how many? We do that a lot as well. Okay, a to the m all raised to the n. This is called a power to a power rule. And you should know, if you don't, that we multiply a to the m times n. And now we have the quantity ab to the m power, and it's kind of like distributing that exponent. We have a to the m, b to the m. Take a moment, get that written down. I will try a few with you. What number am I on? 15, I believe. Well, my notes say 16. So I don't make myself crazy, I'm going to skip right to 16. I probably miscounted somewhere. 3 to the 1/5 times 3 to the 3/5. Which rule is this? 1, 2, 3, or 4? Look back up here. It looks just like rule number 1. The bases, in this case, are 3's, and the exponents are different, so we need to add them. And I am so kind to give you common denominators, so you can add 1/5, excuse me, plus 3/5, so we get 3 to the 1 plus 3 is 4/5. Okay, number 17. 7.2 to the 2/3 power, all raised to the 3/4 power. Now ask yourself, which rule is this? Rule number 3, power to a power. I hope you're getting good at hitting pause so I don't give away all your answers and take away all the fun. So now we have 7.2 to the, and we multiply. So we get 2 times 3 is 6 over 3 times 4 is 12. 6 over 12 is 1/2. So we get 7.2 to the 1/2 power. Number 18, a to the negative 1/3, b to the 2/5, all to the 1/2 power. Here's where we're going to have to use a combination of more than one, so we're going to need to distribute our exponent and move our negative. So I'm going to distribute first, negative 1/6, 1/3 times 1/2 is 1/6, b to the 2/10, which is 1/5. So I'm going to change that to b to the 1/5 because that stays on top. A to the negative 1/6 moves on bottom and becomes positive. So here are some for you to try, and then we will discuss them. So take a moment and write these down and volunteer happily to go put them on the board when we discuss these. Please come in, see me, ask questions, let me know how this video thing is going for you. I would love to hear your lovely suggestions and compliments, of course.